This is the View Pre-Calc class. We're doing topic 5, which is Intro to the Unit Circle, and this is video number 2 in that series. So we're going to walk through example 1, which is in your packet and is sort of written as a table. So before we do that, I do want to touch base about, again, the way that angles are rotated around the unit circle. So I printed a copy of the unit circle here, which is the same copy that you have in your packet, so it's much easier to see there, but just so I have something to point at, right? So we start at this positive x-axis as 0, and if we rotate counterclockwise, we have positive angles, right? So one thing I want you to notice is that there are multiple ways to get to the same spot on the circle. So let's look at an angle of, let's say, 30 degrees. If I start at the positive x-axis and turn to 30 degrees, right, that ends on this side that we would call the terminal side. That's where the angle ends, right? The angle starts at the positive x-axis and rotates to 30 degrees, so that's the angle, right? You can sort of picture this like a hand on a clock rotating, right? The initial starting value of the angle is called the initial side, and it generally coincides with the positive x-axis. And then it rotates to a stopping position that we call the terminal side. So this angle of 30 degrees, there are other ways to consider this angle. What if I set an angle of 390 degrees? Well, that would still mean start at this positive x-axis, but 390 would mean go the whole way around the circle, because that would get me to 360, and then another 30. We'll see how I end at the same spot. Those angles are called coterminal, meaning they share a terminal side, because all of these angles start at the same position. So if they share the same start position, which they all do, they all start on this positive x-axis, then coterminal means that they end at the same spot too. So one easy way to find a coterminal angle is to add or subtract multiples of 360, meaning full circles if you're in degrees, so 360 degrees, or 2 pi if you're in radians, because 2 pi is one full circle in radian. So again, that's one way to do this. So when you look at some of these negative values, one way to handle this if you don't like having a negative angle inside your sine or your cosine is to say, hey, I could find a coterminal angle that is the same angle by adding or subtracting a full circle or multiple full circles, right? So the angle 360,030,030 is also still this spot. It just means that I went around the circle 1,000,000 times and then ended at 30, right? So let's go ahead and walk through a few of these problems, and then we'll stop after example 1, and then we'll go on to some slightly harder stuff in example 2. So in this table, I ask you to list the point you use in the unit circle, just because it's easier. Obviously, I'm not in person doing this with you right now, but it's easier to be able to go back and reference if you use the correct spot. So remember that the sine of some angle is the y on the unit circle, and the cosine of some angle is the x in the unit circle. I always remember it that it's alphabetical. X comes before y, and sine and cosine comes before sine, right? So x comes before y alphabetically, and cosine comes before sine. So let's look at this first. We'll look at 1a. Sorry, wrong way. So 1a asks you to evaluate the sine of 30 degrees, right? So the first thing I'm going to do is I'm going to go to 30 degrees on my unit circle. I'm then going to go to this point. So the point I'm looking at is root 3 over 2 comma 1/2. But since I know sine is the y on the unit circle, my answer is that the sine of 30 degrees is 1/2, just the y value of the point I looked at. In a real math problem, you wouldn't need this step where you locate the point, but you have to locate the point to answer the question. The next question asks you for the sine of negative 2 pi over 3. Well, the problem is that negative 2 pi over 3 is not on the circle. There are two ways to deal with this. You could either say, well, where is regular 2 pi over 3? Oh, it's up here, right? So that would mean that I started at 0 and rotated all the way up to here, and then you could, in theory, just stop and do the same thing in reverse and find where you'd end up. The other way to do it is to say, hey, negative 2 pi over 3 isn't on the circle, but let me add a full circle, right? So I'm going to do FC for full circle. That would be negative 2 pi over 3 plus 6 pi over 3, which means that it's the same location as 4 pi over 3. And you can see that if we go back to what I just did a second ago. One option is to rotate over to 2 pi over 3 and see where it would be, and then say, okay, that's the first line past 90 degrees going in this direction. If I went the other way, it would be the first line going past 90 degrees this way. Oh, look, that's at 4 pi over 3. Once you realize that you're looking at 4 pi over 3, you'd look at this point and say, okay, that's negative 1/2 comma negative root 3 over 2. And I know sine is the y on the unit circle, so my answer will be a negative root 3 over 2. Up next, we have the cosine of 225. So again, I'm going to find 225 on the circle, and it does appear on the circle. It's right here. I'm going to notice that that point is negative root 2 over 2, comma, negative root 2 over 2. And I know that the cosine is the x-coordinate, not that it would really matter in this case because they're the same. So I use the x-coordinate, which is a negative root 2 over 2. The next one is cosine of pi over 2. Well, I look for pi over 2 and find that it's right here. The point here is 0, comma 1, and since the cosine is the x-coordinate, that means the cosine of pi over 2 is a 0. And then for the last one, we have the cosine of negative 5 pi over 3. Now that runs into the same problem. So negative 5 pi over 3 doesn't occur in the circle. Regular 5 pi over 3 does. If you notice, it would be like rotating the whole way around to here, like making almost a full Pac-Man, right? So starting at 0 and rotating all the way to here. So it looks to me like if I went backwards, I'd be doing that to the same spot, and it would be pi over 3. It is a pi over 3, so you are looking at this spot right here, but let me show you why. So negative 5 pi over 3, if you added a full circle, 2 pi, would be a negative 5 pi over 3 plus 6 pi over 3, which is sure enough a regular pi over 3. So the point I'm looking at is 1/2, comma, root 3 over 2, and since cosine is the x-coordinate, my answer is 1/2. So that's our example 1.